Welcome to the video lecture series on the topic differential equations. I am Dr. Nidhi Jain, and in this series of lectures I am going to discuss various types of differential equations and various techniques to solve these differential equations. Now the question arises, why there is a need to study differential equations? Students, in your school mathematics you have learned how to solve linear equations. In these linear equations, there are dependent variables and independent variables, and you have solved many real life problems like age problem, transportation problem, speed, time and distance problem, money problems and many more. Now what if in such real life problems, along with these variables, their derivatives also arises? Derivatives means rate of change of dependent variable with respect to independent variable. Now when we form equations to solve such real life problems, then these equations are known as differential equations. Some of the examples are population growth and decay problem, temperature problem, geometrical problems and many more. I hope this series of lectures will give you benefits and you are going to enjoy this series. So let us start the series of lectures on differential equations. So let us start with the introduction to differential equations. First of all, we'll go with the definition of differential equation. A differential equation is an equation that involves dependent and independent variables and the derivatives of the dependent variables with respect to independent variables. So let us understand this definition first. What does it mean? First of all, independent variable. X is an independent variable. Y is dependent variable. Their derivatives dy by dx, d2y by dx square, or so on. So if any equation contains all these, then that equation is differential equation. We can write it in general form like this: f x y y dash. Y dash means dy by dx. Y double dash, it can be up to nth derivative. So y nth derivative equals to 0. So this equation is known as differential equation. It is not necessary that right side should be 0 always. It can be any function of x. So we can write capital Fx also. Okay. So now what all different kinds of differential equations are? Look at this. Differential equations are of two types. First, ordinary differential equation. Second, partial differential equation. So what is the difference between these two? Look at that. The ordinary differential equation contains only one independent variable and one dependent variable. But in partial differential equation, there will be one dependent variable, but the independent variables can be two or more than two. So that is the basic difference. In ordinary, we have one independent and one dependent variable. In partial, we have one dependent and two or more independent variables. Now let us look at some examples. This is an example of ordinary differential equation. As I said, differential equation contains x, y, independent variable, dependent variable and their derivatives. So it is not necessary that the equation will always contain x and y and derivatives. The only important condition is the equation must contain derivatives. Y or x may be missing there, but the derivatives of dependent variable with respect to independent variable must be there. So this equation contains the derivative of y with respect to x, which is second derivative d2y by dx square plus a square x equals to 0. Here x is independent, y is dependent. One more equation here we have. Here t is independent variable and x is dependent. Dx by dt whole square plus dx by dt equals to 3. Now see, this equation contains both the derivatives. Both are first derivative only, but x is not present here independently. Even y independently, t independently is also not present there. Now let us see some examples of partial differential equation. Once again, I just recall, partial differential equation contains one dependent variable and two or more independent variables. So the first example is, here u is dependent, x, y, z are independent. As here independent variables are more than one, so we differentiate them partially. Like when we are differentiating u with respect to x, then y and z are kept as constant. That's why we write del, partial derivatives. So del to u by del x square plus del to u by del y square plus del to u by del z square equals to 0. One more example here we have. Here u is again dependent, but the independent variables are x and t. So del u by del x whole square plus del u by del t equals to 0. So here you can see the difference between ordinary differential equation, partial differential equation. Few examples are also included here, and you know how to write any differential equation. The general form is function, any function of x, y and the derivatives of y with respect to x. The right side here written is 0. It is not necessary that it will be always 0. It can be any function of x. That's all for the introduction of differential equation. Now we will be discussing about order and degree of differential equation.